Our next FRQ type uses area and volume, which is really just like applied integral questions. Again, how do you know it's an area or volume question? They say find an area, find a volume. It's pretty straightforward in terms of identifying, okay, what is it? All right, so what are the three big things we know for area and volume? To find the area between curves, you take the integral of the starting point to the ending point of the section, and you take the top function minus the bottom function in your integral. All right, if it's a volume with equal cross sections, you'd still do the same starting and ending point, and the thing you're integrating is the area of whatever shape it is. So if it's a square, it's the side squared. If it's a semicircle, pi r squared over 2. Whatever shape you're doing, that's what you're going to put here, and just make sure you put your function in the right place. And the volumes of revolution, remember that's basically creating a bunch of circles, so it's pi r squared, and the radius is your function. Or it could be a little bit different. Draw a picture, figure out what your radius is. But if you know those three things, those are going to be helpful. All right, so here's our picture. Again, you might look at this one and instantly think it's a graphical analysis question because there's a graph, but as soon as you start reading, you see first part is area. All right, so it's not a graphical analysis question. It is an area volume question. So find the area of the region enclosed by the graphs of f and g. So it's literally the first thing we do. It says they intersect at -2. And then b, we don't know what b is, so we need to figure out what this intersection is. So we would set these two things equal to each other using our calculator. It's a calculator active question. Using our calculator to figure out this x value for b, and that should be probably worth a point. Yep. All right, so figuring out b to set up your integral is worth limits of integral. So yeah, figuring out b is actually that point there because you need to have the limits of your integral correctly. All right, top function minus the bottom function. Notice again, they don't copy down what f is and what g is. They just type in f of x minus g of x. If something is defined as having a name, you can reference the name instead of the full function. So you can just save your time. Again, it might not be something you're comfortable with, and there's no problem. Just make sure you copy things down correctly. And then you get basically the last point. If you've already done 1 and 2 correctly, you should get 3. Just make sure you're not making mistakes when you're plugging your thing into your calculator. All right, so part A is 3 out of the 9 points. And I think it's a pretty straightforward question. You're figuring out the intersection point, which we know how to do using our calculator. You're setting up top minus bottom, which we've done plenty of times. You're typing an integral into a calculator. I don't think this one is very hard, and you already got 3 points on this question. All right, part B. All right, again, you're in the region. H of x is the vertical distance between the graphs of f and g. Is h decreasing or increasing at -0.5. So the hardest part of this question for me is what is the actual formula for h of x? But if we go back to our picture, it's the vertical distance between these two graphs. And you can see if we're just finding the distance between the graphs, it's the top function minus the bottom function. So they're a little sly with how they define h. But now if I want to know h is increasing or decreasing, I know to take its derivative. And you can see that's worth a point. Taking its derivative, plug it in, all this stuff you can find using a calculator, and that gives you the answer of 1. Also, it says give a reason for your answer. The reason something's increasing or decreasing is because its derivative is positive or negative. So make sure you read. If it has a give a reason or justify your answer, you kind of have to write the sentence at the end. Why does all the work you did lead you to the answer? I think that was a harder 2 points than the first 3 points. All right, the region enclosed has cross sections that are squares. So this one should be really straightforward. You can get A right, you can get C right. The only difference, instead of just f of x minus g of x, that base is now a square. So we take the base of the square and then square it. Right. That's the integral. It's worth 1 point, just writing it. And then getting the right answer is the second point. All right, I think those 2 points should be fairly straightforward too if you've been practicing. All right, then part D. This is one of the ones that comes out of nowhere. The vertical line travels from the left to right along the base of a solid described in part C. So the vertical line is traveling left. Line is moving at a constant rate. Find the rate of change of the area above the vertical line. So what is the area above the vertical line? That's what we just found. We want to find its derivative because we're trying to figure out how it's changing the rate. So we need to do a derivative, which is here. And just plugging in the values of everything. This one, a lot of times part D, like the separator from the 4s and the 5s. So sometimes you might read D and have like no idea from the start because they're a little tricky with like Okay, a vertical line is traveling on the xy plane. All right, these are the difficult questions. But if you know how to do them, that's great. And a lot of times they're things we've seen before. Other times they're things out of left field. If you don't get like the 3 things throughout the whole test that are out of left field, that's fine. You'll still pass the exam. You're not expected to get everything right. This is just one of those ones. When you see the answer, it's more straightforward, but kind of coming up with the answer yourself is pretty hard because they're defining this brand new thing that you might have never seen before. But the other questions, I think for this question, okay, maybe you have no idea what's happening in part D. You still get a 7 out of 9. That's a good score for a free response. All right, so now we have 4 types of free response questions. We're going to just focus on the last 2, which is graphical analysis and areas and volumes. So we're going to practice those in class exclusively, see all the things that come up a lot of times, make sure we can really get the questions we're supposed to get right before we start integrating all the free responses together.